Good morning, everybody, or afternoon. So welcome to this workshop on trying to visualize OpenFOAM simulation data using a tool like Blender, which can provide these kinds of photorealistic renders. You might find this very useful for communicating your research. Perhaps you want to make a nice cover for a journal article. You might want to put a nice image on the front of a proposal. You even might find it engages students better for your teaching. So in the next hour and a half or so, I'm going to try and give you a good sense of how Blender works, how you can import different kinds of data, and how you can render it. It's a lot more complex topics than we can cover in the short time we have. But hopefully today we'll get a good sense of the basics. And then if anyone has any questions, I'm happy to continue talking to people. Okay. And I'll try and keep an eye on the live Q&A. Hi, Andre in Sweden. Hope you enjoy today's talk. So the way we're going to structure the talk today is I'm going to first of all give you an introduction to Blender, just a general walk around and kick the tires. How do we get Blender installed and how do we use it? And so forth. Then I'm going to go through some simple examples, two case studies, one of a simple axisymmetric supersonic nozzle, and then I'll do the motorbike example as well, is what we're seeing here. This is the motorbike example, how we get these realistic backgrounds and shadows and so forth. So Blender is extremely easy to install. You just go to blender.org and you get the very latest version. Okay, so the latest version is the 2.93 long-term support version. So this is the version to get. It means any of its features will be locked in place for the next few years. So you're guaranteed to have a very stable behavior. Blender evolves rapidly. It's a very, very well-funded and very well-developed piece of software. Whenever some new rendering feature is announced by one of the big graphics card developers, you'll find it in Blender within a few months. So it can be hard to keep up with what it offers, but by installing the LTS version, you're going to have some stability. These images you hear, this image in the background is made in Blender. This was using a new feature that Blender has called procedural geometry. So it's like a kind of a CAD-like tool for generating these very rich organic shapes where you connect up a bunch of nodes in a visual interface to create geometry. So it's very, very powerful, as you can see in the right hand. So just go to Blender, download Blender for whatever OS you're on. I'm on a Mac, but you can get it. Blender runs on Windows, Linux, and Mac, almost anything you want. Of course, if you're on Ubuntu, you can just sudo apt-get installed as well. When you load up Blender then, and we'll do our quick guided tour of what Blender looks like. This is what it looks like. We get a splash screen again with that nice render of those flowers. We just click anywhere and it goes away. And we're presented with this view here. And this view here, I have to keep the Q&A open. This is our default view. Now, Blender's UI can be a little bit unnerving at first. It does its absolute best to avoid modal windows. Every window at all times is fully accessible. No one window takes over and grabs focus. That's its overwhelming design focus. And in the past, Blender's UI could be a little bit confusing because every window can become any other window. So I can move over the corner here and I can tear a window in half. And now I have two 3D viewports. Now, depending on your OS, you can hold down the middle mouse button to control your view. It's very much like any CAD package you've ever used. I'm on Mac OS and my trackpad works. My two-finger trackpad here just works and I can zoom and pinch and all that stuff, which is nice. But every window can become any other. So I have two 3D viewports here. And up in the top left of every window, you'll see a little icon. And I can make any of these anything else. So here, for example, on the upper right-hand side, I have my my properties, my outline. This tells me all the objects in my scene. I've got a cube, I've got a camera, and I've got a light. You see that they all, you can select them all to highlight them. And if I click over here, I can also make this split window here also an outliner. So every window can be any other window. And that can be confusing. And in order to overcome that, what Blender has done in recent years, they've added these tabs at the top. And they're named spaces. So you've got a default layout, which is you can edit any, and any of these can be edited any way you like, and you can make them to default in Blender loads. Anything, you have a startup file essentially that you can edit. You have a modeling one for creating models. You have one for sculpting, which is all about going into So you can edit an object and you can sculpt it. So go to object mode here, I can sculpt and I can start doing all kinds of weird and wonderful things with objects to push and pull them and so forth. UV editing is all about how you wrap an image, how you wrap a texture around an object. Texture paint, well, it kind of explains itself. It lets you paint on objects in 3D, which requires a little bit of work still. We haven't got to that point yet. Shading is something we'll use today. This is how we create materials. So this is the kind of the visual language we talked about earlier in terms of geometry, but also for shading, animation, rendering, and so forth. Compositing is how you add effects after the fact. So adding lightsabers to your OpenFOAM render. And the new one is geometry nodes. This is how we can create geometry with a visual language. It could be quite interesting maybe for interacting with future versions of OpenFOAM, where we can actually create procedural geometry which feeds into a mesher. And then finally, everything in Blender has a surfaced Python interface. So Blender is written in C++, but the entire UI runs on Python. So anything I can do, if I were to grab this cube here and do something with it, so gx1 moves it x in the one direction, and that command that we can see here is written here as a Python script. So you can easily create Python scripts to create geometry or do whatever you like with Blender. So it's very, very powerful that way. So if I were to copy this guy, for example, and just import BPY and then paste that into there, it should just move my cube one more time. So I just basically just got a command that just moves my cube, which then leads me on to how do we move things. So I'm going to go to File, New General. So here's my default viewport. Here's my Blender cube. And the three kind of key commands you need to know with Blender are move, rotate, and scale. So you can see here I've got an XY axis on the XY plane. So Blender is Z up. So if I press the G key, I must select my object with left click, press the G key, I can move things around. If I press the X key, then I can constrain it to the X, the Y key to the Y, and the Z key to the Z. If I press Shift Z, I'm in the XY plane only. So a very, very powerful way to move an object. Now you'll notice that at the middle of this cube, there is a little orange dot. That's the cube's origin. You can think of it as being centroid or something like that. Now, if I press the R key, I can rotate about that object. So if I were to move over here, and then press R, and again, RX, Y, and Z. So let's just go and rotate something like this. Now, I want to move this guy relatively, I'm going to move it in the Z direction. It still moves in the global Z. Press the Z key again, I can move in the local Z. And the same for X and the same for Y. So very, very powerful. And up here at the top, I can change how it moves. So it's moving around its median point, which is this point in the middle. I can also just move around the 3D cursor, which is this little circle you might just see here. So now I can rotate it around that point. Again, this is like any CAD package or 3D modeling package you might have come across in the past. If I want to undo all that, I just press Alt-G and Alt-R. So Blender remembers its origin. On the right-hand side of this window, there's a little arrow here I can click, or press the N key to open and close it, and all those positions are recorded. So I can press G, X, 10, and it tells that it's moved 10 positions, and then Alt-G just remembers that. Now you have to be very careful when you move objects and scale objects. Sometimes you don't always get the consequences. It can have unintended consequences. So what we often do is we use edit mode. Anyone who uses Vim will be very familiar with this workflow. It's very much like the text editor. So we have a general mode where we can just move things around in a global state. We press the Tab key, or go from object mode to edit mode, so Tab. We're now editing the individual vertices. We're like in our insert mode in Vim. And now we can grab a vertex and we can move that around. Or we can grab up here, in the very, very top here, we can grab a face and we can move that around. So edit mode and object mode. So you can see if I rotate this face about Z by 45 degrees, I'm going to get an unrealistic shape. These faces are no longer flat. That's completely not going to work. That's a geometry I can't 3D print, for example. So this is undo that for a second. So Control Z to undo, Command Z to undo. What I'm going to do is I'm going to press Control R. So I'm in edit mode, press Control R, and I can just add using page up, add a whole bunch of loop cuts. And now my object has more geometry associated with it. So it's a way to add geometry. But now if I rotate about Z, I'm back to square one. So we can go up here to this guy. It's called proportional editing, and you can control a fall off, a smooth fall off. And I can press or Z. And this circle that we see here, I can just use my mouse wheel to scroll. It determines the degree of which I can control this guy. And then we have a nice shape that is made out of flat faces and can be 3D printed or imported into your mesher, for example. And this is great. So we have a geometry. We also have a camera. We have a light, which means we can render. So if you hold on the Z key, we get this radial menu, and we can look at the rendered view. And we can see not much is happening. Now, Blender has two renderers. If you click over here on the side, on this panel here, this contains all the various properties of things that we care about. This is the properties panel. And this has properties for the tool we're using, the render settings, the output settings, the world settings, the scene, and various other things we'll come across. Now, in the render settings, you can see there's two options. There's render engine is Eevee and cycles. Actually, a third one called Workbench, which is what we're actually seeing now. Workbench is just the non-render view, I suppose. Eevee is what's called a real-time renderer. And Eevee is essentially what you have in a video game. It's designed to fake things, make things look reasonably good, but be incredibly fast. Cycles, on the other hand, is basically path tracing. And it can use your GPU if you have one. And it can render things, and you can see as I move things around here, you can see things get a bit noisy because it's firing essentially photons from the camera and watching how they interact with surfaces. And that doesn't always give you a clean result unless you let it render for longer. So if you want quick and dirty, use Eevee. If you want photorealistic, use cycles. So just for example, we'll just create a new file real quick, and I'll show you what cycles can do. So I'm going to, in my object mode, I'm going to add mesh plane, scale it by 5. Grab this cube, G, Z, and I'll bring it just above the surface. There we go. Now, this plane, we can add materials. So again, of all my properties here, the second last one on the bottom here, this red kind of crisscrosses are my material properties. And I can add materials to my object. And what I can also do is I can just go to my shading workspace here. It's the same idea. It's just a better layout for using materials. So I'm going to click on this bottom plane. Now the plane, the cube by default has a material. And this was what's called the principal BSDF. It's bidirectional scattering function. So basically it simulates how a probability distribution how photons hit a surface. So if it's very glossy, they all bounce off at the same angle. If it's very diffuse, they all scatter at different angles. And the base color here, I can just pick a color. Now you'll see that this guy has he has shading associated with him. If I were to just, instead of using a shader here, I can just disconnect this material. This is my material. This is the output of the material. I can just add a color. I can add a RGB color. Let me see, I'm going to add a color node. Where is that going? I can't find it. I can just search. And we can have a vertex color, for example. We can plug that into there. We get a constant color. We can search for RGB. So I have an RGB value. And whatever color I plug in here, you can just see we get this non-3D, just flat color. No matter what we do, we get a flat color. So instead, I just grab my shader and I put it in between. So color into base color, and then the output of the shader into the surface. And now it catches the light appropriately. And I can change that color as I want. And I can even use wavelength if I want to use a light source. This guy here is got no material, so I can click over here, the new material, or I can click new. It's the same button. This button here and this button do the same thing. They make no difference. But if I change the renderer back to cycles, and thinks about it further, I press the Z key and I go to rendered viewport. What you'll start to see, and you can see this as very briefly, what will happen is we'll actually start to see some green color shading coming into the material here on the ground. So we're getting this light bleeding effect. And the longer I leave it, the better. Now this, as a piece of ray tracing, doesn't look particularly nice. You see there's some nice reflections here coming off, but it still doesn't look particularly natural. And that all depends on the world. The world lights things in a very complex way. We go outside, the sun is bouncing off particular surfaces, bouncing off the road, bouncing off the grass, bouncing off glass buildings, all around. And it causes quite interesting lighting effects. And to do that, we can control the world lighting here, the background. And by default, it's just using this gray image. And then there's a light source here. And I can just click the light, press X to delete, and now get this very, very boring dark world. What we can do is we can go to a website called HDRI Haven. So this website is free to use. You can buy them a coffee if you like, but you can download a whole bunch of different images. Okay, so I'm going to just pick one here that looks nice. These are 360 high resolution HDR images. They've got lots of dynamic range. So we have a nice Chinese garden here. I'm going to download the 4K version here. I'm going to pop it into the folder here so we can grab it real quick. So it's a HDR file, .hdr. So you can see it's a 3D spherical image. Okay. So what I do is I just click on where it says color here in the world properties, click on the yellow guy and click an environment texture. And we can see nothing happens, everything turns pink. Pink is the universal color of a missing texture. So I'll click open. And in my folder here, here's my Chinese garden HDR file. Click open image. And now what we have is our beautiful cube in this Chinese garden. Now the Chinese garden image is a sphere at infinite distance. So it's not going to directly interact with it just yet. Okay, so you can see I can put it there on the footpath, and the lighting we're seeing, I've deleted the lighting we're seeing is coming from the sun in the image. So that's a realistic lighting. You see the lighting on the cube appears to match the lighting on the ground. Now if I select my ground plane, I go to its object property, which is this little orange box over here, and I can change its visibility to something called a shadow catcher. Now you can see it appears that my cube is in the world. But of course, I can do a lot more than that. I can remove this green material and make it a gray material, and I can make it very metallic and very smooth. This principal shader has all these properties you can change, such as how metallic it is. You can input an image and give it scratches, and how specular it is. This principled approach comes from film Wreck-It Ralph. So that idea of creating objects based on physical principles rather than just more computer science based ideas. But now we can see here's our cube, and our cube is reflecting the world around us. So we've put an object into a 3D world. And what we want to do next is we want to try and get this workflow working for data from OpenFOAM, and in particular from ParaView. So we're going to use ParaView as a middleman to achieve this. Okay, so I'll just quickly check for any questions in the Q&A. Okay. Okay, so that's a very, very basic introduction to Blender. For those of you, I mean, Blender is a complicated program. It does a lot of things. It's a bit of a jack of all trades. It can 3D model, it can render, it can composite, which means drawing things over your render. Some really nice line graphics, for example. And then once it creates some nice user manuals, Blender is fantastic for creating inked outlines. It can edit photo, it can edit video, and you can actually motion track video. So there's even a potential for them. If you had a video, let's say you had a video of a camera moving through a wind tunnel, for example, or a video of a camera attached to a race car when it goes down a racetrack. You can motion track that camera motion, solve for the camera motion, and then place your CFD simulation data into that moving video, for example. So I'd recommend going to the Blender website. They have some really nice tutorials on their website just to get you used to using the software. If we were to do a Blender training session today, we'd probably be here for the next 7 or 8 hours, and this is not really the point of today. So what we're going to do next is we're going to look at an example here in ParaView that I've set up. This is a simple converging diverging nozzle. It's an axisymmetric simulation. This is what we use in our mechanics of fluids module here, where I teach compressible flow, and we have a lab experiment where this nozzle is instrumented with various pressure taps, and then the students try and calculate the location of the shock wave. The problem with this experiment is that everything's enclosed in this very robust apparatus. The students don't really get to see what's going on inside it. We can't get Schlieren in, we can't have any optical access. It's all fully enclosed in a great big metal box. So I made a bunch of simulations so that we could show them the evolution of the shock wave as we vary the back pressure and as we ramp the system up from subsonic to sonic conditions. So a very, very simple simulation, deliberately so to keep it easy for the students, but also a good starting point. So let's just take a jump over to ParaView. So here is the simulation. Now this nozzle has a pressure probe down its core, so the actual nozzle geometry is an annular geometry. So the origin is actually somewhere here. So this guy is revolved around, and just model it as a wedge. You can see the inner and the outer edge of the wedge there. And this is just showing the Mach number. So I've got a calculator on here, and I've calculated the Mach number. It's just the velocity divided by the square root of gamma RT. So we have different things. We've got temperature, we have pressure, all kinds of things. Okay, so let's grab Mach number for our calculator. On this guy, we're going to plot pressure. Okay, so we can easily switch from one to the other. Okay. Now, what I recommend you can do is you can actually have multiple instances of your geometry like this, should you want to do that. We'll do 2 for now. So on our main geometry, we're going to plot the pressure. Okay. However, when we export this, it'll export the scene, including all the color data. And I'd like to let Blender control the color data so I can have some control over it. So I'm going to switch my color map here to just simple grayscale using the X-ray one. It's a simple black, white to black. This will let me write whatever color map I want using the shader editor in Blender. And then I'm going to go to the Mach number guy here and do the exact same thing. And of course, if you want, you can go in and you can vary the all these things by going in and changing your limits and so forth. We won't do that for now, but if you want to edit these values later, you can. We can also go to just not plot any color axes here. So there we go. There's our simple row central foam simulation showing our shock wave at some time step. So a very clear shock wave here. So what we're going to do is going to go File, and we are going to export scene. Okay, and I'm going to stick this into a folder on my desktop, call it case 1, and we're going to call this nozzle export. I'm going to save it as a X3D format file. Okay, and I think you can use other formats too, like VMRL, but for 3D and with all the color data, X3D works the best. Now, I am aware that, just save that as well, that PowerView is going to receive a writer for a format known as OpenVDB, so Open Volume Database. Blender fully supports the OpenVDB standard, which means eventually you'll just be able to export your entire sequence, your time sequence as a volume database, and Blender will just open up and play it back. At the moment, we're just looking at single time steps. Animating a time series is more complex. One of Philip Cardiff's students has written a script to do that, and I don't want to take that away from him because he's been working on it himself. So today, I'm just going to focus on a single time step. Okay, so we have now, and you'll notice here, I've turned both of these layers on. You can see both of them. I haven't blocked one or the other, so they'll both come in simultaneously. That's the important point here. We've saved as our X3D format. Now we're going to go into Blender, and we're going to create a whole new scene. So Command N or Control N, create a new file. We won't save our Chinese garden for now. Okay, so when Blender starts off, it creates a camera, it creates a default cube, and it creates a light source. And you want to get rid of them all. So to select everything, you just press the A key, not Control A, not Shift A or Command A, just press the A key. And then Alt A undoes the selection. So same G to move and Alt G to unmove, or Alt or to unrotate. There's A to select and Alt A to deselect. So there's A, X, Enter. So see how it's quite Vim-like. You know, it's very, very quick commands. So a sequence of keys followed by the Enter key. So now we have a scene with nothing in it. You have a collection. The collection is just a folder of objects here in our outliner, so you can have multiple collections. And this 3D cursor, you can move it around with this tool. This is our insertion point. This is where in 3D space things get inserted. Shift C puts it back in the center. So typically we won't worry about him for now. So File, we're going to go to Import, and we're going to use the X3D import option here. Okay. And now we can see if I go to my case 1 folder here, I have my nozzle export. Now Blender is Z up, so I'm going to be Z up. I'll use X, doesn't really matter, I'll use X forward for now. I'm going to import my file. Nothing happened. Did I import or export? Sorry, import. Sorry, I tried to export. Nozzle. So Z up, X forward, import. There we go. I tried to export an empty file. So what we see now is a whole lot of stuff here. Okay, there's a lot going on. If you look at our outliner, we see there's multiple direct lights. So this guy and this guy. These correspond to the lights that come by default with ParaView's default scene. So I'm just going to select those, press X, and they're gone. We have our two shapes. These two shapes here, so our shape index face set, 0 and 001, they correspond to these layers here. Okay, so our Mach number and our pressure data on our mesh. And our viewport then is our camera. And as you can see, I moved the camera back to this position, and then that's remembered. If I had the camera at a different angle, the camera would have that angle too. Now the camera, you might have noticed from our previous camera, this little triangle on top is no longer filled. This camera is not active. If I were to go and add, so object, so up here to add camera, or just Shift A, I can add a camera. This camera is different. This camera has a little filled in triangle. This guy doesn't. So this is the active camera. This guy isn't. So it's going to delete him for a second. So the shortcut is just Control-0. So you just press Command-0. And nothing appears, right? There's a reason for that. We'll get to that in a second. Now, if you're on a laptop, like I'm on an Apple iMac here, so to have a keyboard with no numpad, it can be difficult to navigate it first. So by default, Blender makes a lot of very clever use of a numerical numpad. It uses 1, 3, and 7 to orientate your X, Y, and Z position. So 1, 3, and 7 is the top view. And then 5 is used for perspective and orthogonal. And then you can use 4, 5, 7, and 8, and so forth. 4, 5, 8, and 8 to move it around. If you don't have that, if you don't have a numpad, you can still get by. You can go to Edit, Preferences. You can go to then your input setting and click Emulate Numpad, and it'll treat your number row on your keyboard as a number pad. I find it very, very useful to orientate your view. You can also do other things there as well. Also, if you've got a graphics card under here, you can specify that as well. If you've got a GPU, particularly an NVIDIA GPU works really well for rendering. OpenCL has been abandoned, unfortunately, but CUDA is where it is. Okay, so if I press the 0 key on my numpad, I see what the camera sees, and currently it disappears. Something's wrong. Now this simulation is brought in to scale. It's a very, very small geometry. Just for reference here, by default, each Blender unit here is this is 1 meter, and this is very, very small. So I go to my scene tab, which is the scene guy here. You can see that there's a scale. So units, you're using a unit scale of 1 meter. Now you can change that if you like, but there's other ways you can do it. First of all, I'm gonna make the camera a bit smaller, just so it fits the nozzle. It doesn't really matter. So there's my camera frustum. Scaling the camera has absolutely no effect on the camera. It just draws it of a certain size. Rotating and moving the camera obviously rotates and moves the viewport, but scaling the camera has absolutely no effect. It's just a visual indicator. Now, if the camera is selected, you see a little camera icon appears here. If the geometry is selected, a little mesh icon appears. So the camera is selected, and the camera is now our active object. That was Command-0, or you can go up to your view command, camera, and set active object as camera. That's the other way to do it as well. There's lots of things in the menus up here. No questions in the Q&A, okay. So now our camera view is showing us nothing. And why is that? Because this is a very, very small scene. So what we can do is select our camera, go to the camera properties, and you will see that there's all kinds of things here. We can change the camera from a different type of perspective camera to an orthographic camera. Maybe you'd like that. We have a focal length of 67 millimeters here, which is not realistic. Maybe we'll just use a 50 millimeter lens, just slightly wider. And you see this thing here, clip start and clip end. So 0.1 meters. So just making 0.01. And now we can see our object. Just that, depending on what you import, it could be a very, very small geometry. It could be a very, very large geometry. If you're doing something with a geographical flow, maybe 1,000 meters is too big. So either you have to scale your model, or you just have to scale what the camera can and can't see. So obviously 1 meter here is plenty. Now, otherwise Blender is going to try and render all that, it's going to struggle. So the idea is to cull geometry that's far away or too close, so you can still render. Or that thing, that very, very close geometry doesn't interfere with your renders. You can have objects passing in front of the camera that are unseen. So there's artistic reasons, I suppose, for doing this. So here we have our view. Here we have our object. See, there's the origin here. So this object rotates about, if I switch here to the or Y, so X, Y, Z, or GB. So this object is rotating around like that. And there's two objects, okay? One object contains information on the Mach number, and one contains information on the pressure data. So I'm going to move this guy up in the Z, in the X direction. Really. So I have two objects, one here and one here. So the upper one contains the Mach number data, and the lower one contains the other data. Okay, so we're going to try and see how we can look at that. So if I select my camera, move him in the X direction. Okay, if you find something's moving too quickly, holding the Shift key while dragging will slow it down. So how do we get this color information? So if we select the lower object here, and if we go to its mesh info, this little green little triangle guy here, this is the information on the object. So it's the object data properties. What data is attached to this object? And we can see there's different things as vertex groups, which that's a select parts of this object. You can see there's my mesh, which you can see quite nicely. It is all the mesh data. But what if I want to actually see what's in there? So UV maps are, of course, how you map a texture to a surface. There's one already there by default, but we're not going to use that today. If I wanted to map a UCD logo around something, I'd use a UV map. What we want is vertex colors. I think there's one there called color, C-O-L. Okay, we know that is our second object. That's our Mach number, I believe. Okay, and the other one up here, this other object, has a similar one also called COL. So these particular objects have something on them called color. So I'm going to go to my my shading view here, and I'm going to create a new material. Okay, here's my material now. I could use a principal shader. I could use something else. It doesn't really matter. I'm going to use a diffuse shader. Diffuse shader is just a boring rough shader. It's much smaller on the screen, so it's simpler to understand. Now, what you do is you go to your inputs. So I go to add, or I press Shift A. I go to my input, and under input, I can add all kinds of things. You know, of all the Fresnel, camera data, tangent, RGB colors, UV maps, values, and so forth. I want an attribute, and I connect the color of my attribute to the color of the shader. And as you can see, it changes to some color. And this color just represents the UV data. This just tells us that it's X is changing in one direction, Y is changing in the other. It has no information other than the geometry information. If I type in COL, now it's capital COL, we now have our Mach number data. Now go to the upper guy and do the exact same procedure. This time I'm going to remove him. I'm using the diffuse shader because it's compact, it's not taking up the screen, it's not distracting. And the input is our attribute. I can use any shader I want here. Again, COL. And this we can see is our pressure. Okay. So I have two objects here. I'd rather just copy that vertex data onto this guy and then just delete this guy. And then I could switch back and forth between them as I like. And you can actually do that. So the way to do that, so this guy here, we know it's going to rename color to Mach, and I'm going to rename our color here to pressure. Now to go back to my shading, it's all gone horribly wrong because I have to update the names. Okay, so this is going to be Mach, and this is going to be. In this instance, it's not smart enough. Oftentimes it is, but because this is a manually entered field, it doesn't have the smarts to update it. But typically Blender is quite clever in that regard. It will update things for you. So I'm going to select the object I want to keep, Shift select the object I want to get rid of. Now this object here, the one with the brighter selection orange bounding box, that's the one that's primary selection. Okay, so I want to copy from here to here. So I'm going to select the bottom one first, add a new vertex color, so we'll call it pressure. And we're going to, so hold down Shift and then select the top guy. Let's go to Object, Link Transfer Data, transfer mesh data, so basically transferring the mesh data from our active object to the second object, and pick vertex colors. Okay, so now when I go back to my shading, select the bottom guy, so there's the Mach number, there's the pressure. Okay, so I can switch between them now as I like. So I can just delete this upper guy. What I can do is I can do some fun things. I can grab this and this, select both, duplicate it with Shift D. I can add a shader called a mix shader. I can drag him onto that wire and I can plug him into there. So one says pressure, one says Mach. I can go 0 and can't spell. There's my Mach number, there's my pressure. And I can start jumping between one and the other. So now I'm starting to have some sort of control over what's happening. Any questions? What's nice about Blender is almost every single thing you can edit can be animated. So I can create a keyframe at 0, and then at a later time create a keyframe at 1, and it'll animate from one to the other. So it's very, very powerful. Now, at the start, when I was in PowerView, I said I was going to try and keep the color grayscale so I can edit the color map later. So let's do that now. So I can add a converter color ramp. Okay, I'm going to add it onto this guy for the time being. Okay, so the color ramp, as you can see, there's absolutely nothing. And if I flip these guys around, you can see I can start to adjust it. By keeping it grayscale and linear, I now have that control. If I had kept it in a RGB kind of jet style color map, I would have lost that because it adds artificial contrast and it's non-linear. So let's just add a few colors here. So I'm going to make this guy blue. So I'm going to make our own jet color map. I'm going to make this guy red. I'm going to add one in the middle, which we know should be green. And there's our lovely little color map. We can add a few more as well. We can add the cyan, for example, and the yellow. So it always adds one to the left. So now we have a color. We can control this any way we like. So we can even use maths nodes here to offset the value for us. So all kinds of interesting things we can do. So we can change the factor. Now we're going from one to the other. So I can add in. I can duplicate this and add him there. I can edit it, whatever I like. I've got full control now over that. So as we can see, if we go through our notes here, we have our object. We've copied our vertex colors, and we have removed it, and now we have our color map. Okay. So the last thing we want to do on this is just to take it and just rotate it around to give it that axisymmetric look. Okay, and then we can move on to the motorbike example. This will be the more interesting one. We've time. We've got 50 minutes left. Excellent. So Blender can do all kinds of interesting things in terms of arraying objects. So Shift B gives me a zoom box, so I can zoom in quite easily. So this is our origin here, and this is our object. So what we're going to do is we're going to add what's called an empty. An empty is just a reference point in space. So Shift A, add an empty. You can add different ones, doesn't really matter. I use the arrow ones for the time being. So here it is. Here's my object. This is my XYZ coordinate. I scaled it down a small bit so you can see it. And I want to rotate this guy about the Z axis using an array modifier. And what is an array modifier? Well, Blender has lots of these things called modifiers. Anyone who use Photoshop would be familiar with its adjustment layers, and they're kind of the same idea, but for 3D graphics. Okay, sorry, we're back. Can everybody hear me? Okay, so just answering some questions that came up. So the first question was, is it difficult to make a color bar? So I've just demonstrated that it's not, but it's important you keep a linear color map, a grayscale color map as your color map within your within PowerView. The notes and slides should be shared. I'd sent them out at the weekend to be available, but I will make them available if not. I had sent them out to be uploaded. Okay, so what we wanted to do, we wanted to array this object, and we wanted to array it around in polar coordinates. And I've created this little empty here, this XYZ axis. So there's all kinds of modifiers that you kind of things like Boolean, where you can take two shapes and you can non-destructively combine them or subtract them from each other. We want the array modifier. And as you can see, it just duplicates an object multiple times using this vector here. So we can just change that to be in this direction, for example. But that's not quite what we want. Okay, we can have it many, many times here, we can see. And we can change this scale and we can do all kinds of things. But what we want is an object offset. Okay, we want to offset based on our empty. Okay, and if we take our empty and we rotate it around the y-axis by about 6 degrees, or more even. Sorry, I need to fix that first. We take our object, we rotate it about our object here. This is not working for some reason. I've done something wrong. I think this guy needs to be unrotate him. I believe it only rotates around a certain axis, so I need to rotate him around. So I've forgotten how to do that, unfortunately. But essentially what you will get is your object here will look like this. So you can see here, I've got a fixed count, 30 objects, using an object offset using our empty. And I believe I just need to rotate this guy, so it rotates around the y-axis or the z-axis. So I can just do or z90. And then if I pick my empty here, I rotate this guy, I should get copies of this guy. And that's it, and that's then your guy set up. In this case, it's not ideal. And then what I want to do is I want to export that out. So I can just go to my viewport here. I can go to my output, my printer icon here. I can specify a resolution here, so this is 1080p. A folder where I want to put things. By default, it's your temp folder, and it outputs PNG files by default. And then under my render settings, I can specify which engine I want to use, EV or cycles. For example, if you want to get a transparent background, perhaps, you would go under film and click transparent. And then up top go render image. And there's our result. Now this looks very, very dark because there's no light source. So what you may want to do is change the material. I've used a diffuse material here to this guy. You can replace him with a different material, like a emissive material, or you go to the world and you make the light infinitely bright. And then if you go to render image, we end up with this image here. And the checkerboard indicates it's a nice transparent background, which is good for putting into presentations or incorporating into a video, for example. So that's the first case study. Now we are going to go and switch to the motorbike case. Okay, so so PowerFOAM built in. So here we have our motorbike case. I've actually got one, I think actually already here. So here's a case I made already. This is just, I have the OBJ file of the motorbike. I have stream tube plot showing velocity and a slice here showing pressure. Okay, so it's a pressure slice, there it is, okay? And you can make these guys whatever you want to make them. So stream tube, motorbike, and so forth, okay? So here's our geometry we're going to work with. Now this is I've turned off the main volume because this is just too much information, but there we go. So again, we can do file and export scene, and we're going to export this into my case 2, and I'm going to just call this MD1 for motorbike, and I'm going to save it as a X3D format file. And I won't bother with the color legends. Depending on your version of PowerView, that'll be slightly different. Okay, so we won't save this. We'll create a new Blender case. Any other questions? Okay, so first thing is just for this convenience, because we're adding loads of extra geometry, I'm going to select all with A, X, and enter. So now we're going to file. We're going to import our X3D format file. It's in case 2. Again, Z up and X forward or Y forward, doesn't really matter, as long as you're consistent. And this is a more complex mesh, so think about it for a second. And again, we have all these direct lights. We can just press Shift select to select them, X to delete them. Our viewport is our camera view, which if you can't find it, is over here. So pressing the home key will find your camera. And just press Command 0 or Control 0. So there's our viewport. You mightn't like that viewport. You might prefer something different. So if you press the N key, go to the View tab here, you can lock the camera to your viewport, and you can just use your standard, CAD controls. I'm using my trackpad here to position the camera how you like. It's up to you how you do that. Okay, and then you turn it off again so that the camera is now locked in place. So this is fine. This looks good. We want to do a few things here. We want to go back and add these. So if I select these streamlines, for example. Now, one thing you'll notice is that this model, and if I press the / key on my Numpad, I can isolate this model all on its own. This model is troublesome because it is a single mesh. Okay, what you actually need to do to get it to work as independent components is to, let me just open up my, use the surface split by patch command in OpenFOAM. That will let you take that OBJ file and split it into its constituent components. Okay, and what I have there then is all these individual files, all these individual components that we see. So the helmet, the visor, the boots, the handlebars, all that stuff. So that's much easier to work with. So I'm just going to delete him completely. Okay, and then /. So the mesh is not, that model doesn't work very well for us, because now you can go into Blender and you can use its various editing tools to separate those parts out, but it's easier just to split them up, and you can individually select them. Now the problem is, if we try and import an OBJ file, we can only import one at a time. It'd be very, very tedious to import one file every time and go through the user interface. Now, of course, we know that Blender is scriptable, so someone has gone to do that for us. So we go to Edit and Preferences. We go to Add-ons. Blender has many, many add-ons. Most come completely disabled. Things like inserting extra objects, things like importing images plain. So import images plain is off by default. That's a very, very useful thing to do. To take a photograph, it comes in as a 3D object. So that's what I tend to install. I've turned them all off for today. So if I go to the Install menu here, and if I go to the course notes, and you should have these course notes, if not, I'll make sure they're uploaded. There's an add-on, it's a Python file called batch, OBJ batch import. And just make sure that's saved, so save preferences. So now, when I go up to File, and I go to Import, I should have my batch import here somewhere. Did I import that properly? Sorry, let me just check that. I didn't click the button. That's the important part. You got to click the button to confirm. So it's an extra security step there. Because obviously these things can be malicious if you're careful running any unknown script. So save preferences. file, import, and here's my importer. Now, if we go to my case 2, here's all the files split up already. A to select them all, X forward, Z up. Think about it for a second. This little loading bar appears on your cursor. And now, what I end up with is my motorbike, but each individual component is now separated out. Okay, so now I can, like before, like adding materials to all of these. So I can go into my shading workspace. Now I tend not to do, I tend to prefer just going back into my standard workspace, splitting it in half and changing one of those halves to the shader editor. Just fine, just wherever I was just used to using it. If you use Tmux, you're familiar with this. It all depends on your own personal preference. So each of these objects already has a material created for you. You mightn't like that. You might want to go up here to the top, up in your outliner, there's a little button here, and you can look under Blender file. You can go to all the materials that exist. And I'm just going to give it, they all have boring names, so I'm just going to just delete them. Get rid of them all for the time being. So if I start from scratch then, so I have my helmet here, and I'm going to switch straight away to the cycles renderer. So new material, by default, uses the principled shader because it's the most useful and most versatile. I'm going to add a color to give them a nice red helmet. I'm going to make it very smooth, but not so metallic versus dielectric. So I don't want that. I'm going to Z and go to my rendered view. And you can see there we have a nice helmet. Now, the problem is, of course, that the scene, of course, is very, very dark because we have no illumination. So I'm going to go to my world and add an environment texture. And in the materials, we have various different ones. I think we're going to go with Ostrich Road from HDRI Haven. And we can see we're on the road. However, let's go to hold down Z, go to wireframe view here, and render view. We can see that the bike is not exactly aligned with the road. This slice here is in the way, so I'm going to press H to hide it. We want to rotate our bike, and as we zoom in and out, the bike obviously changes scale. So it's not the best view in the world. So what we can do is we can go to our, down here, this is where we have our shader. We can change from object view to world view. And this is what's determining, what I did over here is what determines how everything works over here. So I can add an input, and I can add a texture coordinates input. This is all about the texture coordinates of this input image. And I can click generate it and map it to the vector. And then I can add a vector mapping mode. And I can rotate around the Z by 45 degrees, so minus 45. Let's see. So if you see the motorbike here is facing the wrong, he's going the wrong direction, so try minus 45. There we go. Now that looks much better. Our motorbike is now traveling down the road in the right direction. Now, my camera view is facing the completely wrong way as well. So we look back at our view layer here. We have a viewport. Our camera viewport is somewhere here, selected. So the shortcut is so view, camera, viewport. So to align the current camera with the current view. Did I delete my camera? I might have. So I'm just going to press add camera. Okay, and pressing the 0 key will show me, okay, there's a camera there. Okay, delete him, go back to our new camera. I've lost track of all my cameras. So add camera. And the camera then is this guy here. So just press Control 0. Sorry, I just lost my cameras again. Why are there too many cameras? Okay, we have a software freeze here. So occasionally Blender will freeze. It's generally quite stable, I find, but occasionally it can happen. If the worst does happen, what you can find is you can go back into Blender, and it has an auto recovery option. So you just go to File, Recover, Last Session or Auto Save. You'll find our most recent version was saved today, just a minute ago. So we've recovered quite nicely. And I need to fix my cameras. Just make the windows the right size so I can see all my Q&As. Okay, so here's my camera, Control 0. Now, I need to bring this camera back a bit. So the camera, again, it has its local coordinates. Moving the camera GZZ will move it backwards along its plane of view. So you can rotate the camera about X, Y, and Z. You can change the camera's field of view. We could go with maybe like a 35mm lens here. Now, how does this look? Does this look realistic? Does this look like it's sitting in the plane? So go to our rendered view here. Yeah, that looks pretty good to me. Okay, so our camera, our motorbike is now in the scene. Now, the problem is that the motorbike is not casting a shadow on the ground. So we're going to add on our, see our little 2D cursor here, add a plane. We're going to scale it in the X direction by 2, scale it in the Y direction by 5. So we've captured the shadow on that plane. Go to the little orange box over here, the object properties, go to visibility and make it a shadow catcher. And now our bike, if we select everything, is casting shadows on the ground. Now the next thing to look at here are our streamlines. Okay, so they're not doing those are streamlines, these are stream tubes. So these guys, go back to our object, the new material. So we're going to add an input attribute, connect color to the base color, add a converter, color ramp. Just for the sake of not spending too long on this, I'm going to add a blue one, and I'm going to add a red one, and one in between. Okay. So you can share materials among multiple objects. You just click up here and pick the material. So this one here, I can just call this streamlines. And we can see these streamlines now are starting to look okay. They're not particularly colorful, not very obvious change in color. So what you might want to do is go into your converter and add a math mode. And we can multiply these velocities by whatever we want. And we'll get a change in color, if you like. And of course, we should probably call it the right name. That would also help. So you have a lot of control over Okay, so we're having a few connections. I deliberately came to UCD today to avoid connection issues. So that's pretty good. We have our slice here as well, which we can do the same thing too. I'll leave that to you guys to do. It's also the same material. So now we're allocating materials as we need. So that would take quite a long time to go through. So what I'm going to do is I'm going to open up one I've already made. And this is the same again, the exact same model file. In this case, I've got the same idea set up here. So if I go to the world, for example, you can see I've got my texture coordinates going into my mapping. I'm using minus 40, 60 degrees here. This is the image that I'm using, this Ostrich Road from HTRI Haven. And I've got an alternative one here. I can swap it around. I can switch to a different one. Updates, I can switch time of day to different things. You can see it doesn't always line up because it's not actually physically on the road. It's just appears to be projected on it. So it's an illusion. There are more sophisticated ways to make the actual HTRI image map to the object. That requires creating a dome and matching onto the dome. So we have 28 minutes left, so plenty of time left. What's cool is you can go to your camera. You can select your camera view, for example. You can look here. We can go to the camera settings and we can specify a depth of field effect. And I can focus on the helmet, for example. So the rider helmet is my focus object, or the specified distance. And I can give it an f-stop of something like an f1.2 for an expensive lens. And if I then go to render and render image, this computer is not terribly fast, so it's running on the CPU. What you'll start to see is we get this beautiful depth of field effect. And there's other things you can change here as well. So, for example, you can make sure that the streamlines themselves don't cast shadows. You can make the streamlines. Oh, okay. Oh, okay. So we got cut off there again, and my screen sharing cut out. Apologies. I'm on a wired connection. I would have thought it'd been a bit more stable. Okay, so what I've done is I've gone into the my camera settings, depth of field, and I've specified the helmet here as the focus object. And now, as it renders, you can see that the background is out of focus because it's at infinity, and we get our streamlines nicely out of focus, and our helmet is sharp, or whatever component we care about. So we get some really, really nice effects from this. That's going to take some time to render. It's only done about 20%, so I'm going to just do that again so you guys can see it. So let's cancel that. I'm going to switch to this object here. I'm going to switch to this other camera. So here we're going to do the same thing again. This camera, of course, has, again, the rider helmet as a depth of field effect. Sorry, this needs to be into here. So there we can see our streamlines. Now the streamlines aren't casting a shadow, okay? So I've deliberately turned that. If I select my streamlines, go to their object, and under visibility, I can enable them that they cast a shadow. And now you can see my streamlines are casting a shadow on the road. And that's a decision that you might want to show, might not want to show. So for example, if I turn off the shadow rendering for them, and I change the object, so using principled here, I'm going to X him out, I can add a emission shader. Okay, it's still trying to connect, I think. Okay, anyway, let's just try and continue, and hopefully the recording is good enough. So one of the questions was, is it easy to create a color bar? So if I wanted to add a color bar here, for example, we can do that. So I'm just going to go to my material preview here, so I don't have to worry about my computer trying to render everything. Okay, and I'm going to add here, I'm going to add a cube. Okay, go into edit mode, scale it in Z by, let's say 4, scale it in everything, so shift Z by 0.2, and here, for example, then is my cube. I'm going to scale it in Z by 0.5, Z, there we go. There is my, let's say my 3-dimensional color bar. Okay, we might make it a little bit smaller, just so that it fits into our field of view. Okay. Back again. Oh dear. This is very frustrating, I'm afraid. If anybody is very interested in having a Zoom call or something with me, okay, this is continuing to disconnect, which is making it quite difficult to continue, but I think we've covered almost all the main points we wanted to cover that were in our lecture materials. So just to kind of maybe reiterate by going through the slides while we try and get some sort of connection here. So we've added our add-on, which says import multiple OBJ files. That suits your particular workflow. We have our various model components. In here, I didn't do this in the actual demonstration, but if you wanted to, because each of these parts are individual components, you can easily pull them apart from each other. What you can do is you can parent one object to another. So all the subcomponents can be parented, in this case, to this axis. So I can move the axis to move all the, otherwise I'm moving everything individually. That's just a bit of organization. It's like creating a subfolder. Here's our scene in ParaView and exporting as X3D. And of course, it's important to work in grayscale if you want to edit the color map after the fact. If you don't care about the color map and you're happy with it as it is, leave it as it is. Remember to bring things in as Z up and then be consistent, whatever your forward direction, as long as you're consistent. Bring it in the Blender. You can create your materials. Again, it's going to be an attribute with the name that we care about plugged into our material pipeline, and we get the effect that we want. We can apply multiple materials to our bike. Here I've created a tires material. Grab the HDRI from the HDRI Haven website, plug that in, and we get our object on the road scene. We use the shadow catcher to convert this ground plane into a material that only casts shadows and has no other transparency. One issue that came up as well when I was preparing this, I found that the visor, the glass windscreen, needs to have a certain level of thickness. It's infinitely thin, so you just use a solidify modifier to give it a minor bit of thickness, and that lets you get a nice glass effect. Otherwise, it's like a lens, which is kind of unnatural looking. Minor little things that can be easily fixed. And we can control the camera, we can align the camera. If you find that you can't get the camera quite right, you can shift it. You've got an X shift and a Y shift. It's essentially moving the sensor around inside of the camera lens. That can give you a bit of control without having to worry about the background. So there's several ways to control how the HDRI is positioned. So you can rotate it. I'd avoid shifting it, just rotate it, but shift the camera, not the HDRI. And if you look up online, there's various projection techniques, such as mapping the HDRI to a physical dome as opposed to a background to get the result you want. Or you can just use any background you like. You don't actually have to use a HDRI image. You can make a background. You can import a still image as a background. It all depends on what you want to achieve. Rendering then is set up by clicking at this little thing. This image is the back of the camera. This is how you set up your camera. This is how you set up a virtual camera in Blender. So cycles for ray tracing. And these guys here, these numbers, this number 128, this is how many samples, how many essentially virtual photons each pixel is receiving. So the higher this number, the slower your render, but the cleaner and the better it looks. The lower this number, the noisier your render. And you can specify where it goes. So by default, it goes to your temp folder, but you can specify any folder you like here. You can specify the resolution of your image, and you can also do animation here as well. And then finally, up top of the screen, render image. Animations also can be done. And then once it's done, you just save an image. When you're rendering an animation, it automatically saves your images. And that's the result. I'm going to try one more time to try and reconnect here. If it will let me. Temporarily unavailable. So unfortunately, we are struggling to get a connection to the platform, which is very unfortunate. So one last thing I'd like to show you, just for fun, while we have a few moments, is how you can do fluid simulation in Blender. Okay, so that's quite a nice thing that you can do. So I'm going to start off with a simple example here. I'm going to just take this. I'm going to do like a dam break type simulation here. So I'm going to go to work in wireframe mode. I'm going to add a cube here. So you can see the cube. So SX 0.5. This is kind of a very simple dam break type situation here. We have our domain here. We have our cube. One cool feature of Blender, if you hold on the D key, you can just start drawing on things. It's a very nice way to annotate what you're doing, should you like to teach with this. I used it for teaching quite a few times. It was quite nice. Students appreciated the interactivity of it. I'm going to add another cube here. We're going to pull it in the X direction a bit. I'm going to just go into edit it a bit. And my front and my back plane, and bring it in the S direction. So this is going to be my fluid. This is my dam. This is my domain. So I just need to go to my physics tab here. In physics, I can do all kinds of things like collision and plot and fluid and rigid body. Rigid bodies are very, very fun. You can have lots of objects crashing into each other. We actually had a student this year who did his project on using that to simulate a Galton board, and it worked surprisingly well. So in fluid, so pick fluid. we're going to go with a domain. So this is our domain, and it's going to be using a liquid rather than a gas. You can do gases separately as well. This is built on the Manta flow engine. So basically, it's a flip method, it's a particle and cell method. This is going to be a effector, and it's going to be a collision object. And then this guy here is going to be a fluid. It's going to be a flow, and it's going to be a liquid, and it's going to be a liquid geometry. Okay, so then I select my object, and we can just scroll down here. And now there's different options. I'd like to use the modular option because it lets me independently bake our simulation. There it goes. And I can watch this simulation playback. So very, very nice. And then of course, what you can do is you can go into the option to take that point cloud and mesh it. And if I just bake it again, let it run. And of course, you can increase the resolution and so on and so forth. My mesh should have been made, but didn't. Free data, create a mesh. You can control viscosity, all kinds of things here. Oh, sorry, I need to switch this back to the all case, there we go, and turn on the mesh, and then click. Make all, there we go. And what I end up now is a nice mesh. So it's a quick and dirty way to create a fluid flow with very little effort. This is very, very nice. So I've used this in the past to create some examples that demonstrate how viscosity works for free surfaces and things. It's a very nice way to create a simulation if you want to achieve something like that. My inflow here, you can see, is a type of a flow. And it's a liquid geometry. It's a constant source, but you can turn that off. You can have it as just a simple volume of fluid as well. And I think that's probably all we have time for today. I find Blender incredibly well designed and powerful software, but with a very steep learning curve. So in the time we have today, it's very difficult to show you everything, but at least gives you a taste of the kind of the imagery that's possible should you want to promote your CFD using these kinds of tools. Apologies for all the connection issues that we had. If anybody wants to contact me at kevinnolan at ucd.ie, so kevin.nolan@ucd.ie, I'm happy to talk to anyone about this. There's a lot of fun creating something visually striking from your simulation work, so I'll be happy to help. Again, apologies for all our connection issues. Thank you.